sure I'm recording. If ever you need any of the class that we dealt, you can see it. So program is very specific to programming coding, whereas algorithm is very specific to pseudocode. Pseudocode, it means the way any task is presented in human understandable language. It's not at all anything to deal with coding, but it's human understandable language. Pseudocode is also similar to a chart, which I showed you yesterday, a flow chart, where there will be just steps for solving any problem. It could be a simple making tea or simple addition of two numbers. So sometimes if people use this interchangeably, we get confused. So it's better to be specific with program and algorithm. And as I said, again, program is a step-by-step code to solve any problem. Whereas process is also very much used in programming language. Process, it means a step-by-step procedure or step-by-step approach to execute a full algorithm or to execute a full program. So when we have a program and it's written in any language, it could be C or C++, and now I'm trying to execute it. So to execute it, it will have any process. So that process we call as a step-by-step approach. Clear? Okay. Let me tell you again. In the process of execution of any algorithm, there will be some steps. That steps are called process. Are you able to get it?
Yes.
All right. Next. So we are doing all of these just to solve any problem. For solving any problem, the first step that we need to do is define the problem. What do we mean by defining the problem? We just have to know what is the problem. Like I told you, I need summation of two numbers. So how would you define this problem? You will say, find the sum of two numbers or find the addition of two numbers. So you have defined it. The second step that you will do is outline an approach for solving the problem. Here, what we are trying to do is we are doing the full outline, the skeleton or the structure by which we can solve this problem. We are trying to give an outline of it. It means we are trying to just getting the solution in a very broader way from the overview, like an umbrella. Next, we will execute the plan. We will see and try to execute the plan using any programming language. We will see if my plan, my outline, is it working or no. After that, you will see what's the result. Is this program giving me addition of two numbers or no? Okay, if it's giving, that's good. Now, I'll take a very big number, maybe 10,000 plus 10,000, and I wrote a program for very small numbers, and I am giving the input for very big numbers. Then it will not give me the accurate solution. So I have to check my answer for accuracy again. If I need more accuracy, I have to change the program a little bit to make it solvable for big numbers too. So these steps will be repeated, continued for a long time until and unless we reach a very good, correct solution. Okay, right? I hope you are more clear today with all of these things, right? Now, we are revising pseudocode, which will describe the algorithm, the process of solving a problem in a natural language. So we will write all the algorithm in a formal language. There are some rules. The rules are little close to programming language, little close to any coding language, but they are not similar. They are little close, okay?
Mhm.
But to write an algorithm, we need strict syntax rules. For algorithm, like for any program, we need syntax rules, but for algorithm or for pseudocode, we don't need.
Yeah.
And this will help us to understand more and increase our readability of logic. Like we'll know, okay, what's the logic? We will understand more. Okay. So here there is one example we are giving.
Mhm.
I have a variable name. What do I mean by variable? If I want to store some value in computer, as I told you, computer will store it in its memory. For
Mhm.
storing it in its memory, we need to give name for that particular memory. And we call it as a variable name. Whatever thing that you want to save, you need to give name. So this is the variable, and whatever the value that you want to store, you have to store it after equals. Okay.
Yeah.
Example, this is the gross payment. So gross payment is my variable. It is
Mhm.
my place in computer memory, which will store the value of gross payment.
Yeah.
And basic salary is also a variable which has already stored the basic value of some person plus some commission that the person gets at the end of the month or sometimes. And this two addition is giving the gross payment of that person. And that is saved.
Yeah.
Right? You understood it, right?
That's
Okay. Yeah. Yeah. And just let me show you here. If, yeah, we have a box where we are storing a number called A.
Mhm.
And then there is another box where we are storing the number called B.
B.
So its name is A and B. Here, if we store value 2, the computer will remember. And if we store value 3, the computer will remember. And the addition of these two has to be stored in another variable called C, and addition will be 5. And the computer will remember like this. Okay.
Yeah.
So we are allocating the place for in the computer memory. Right.
Yeah.
Okay. Then we have the same thing again. We are continuing. We have understood, like we discussed in short, what is meant by iterative constructs. Iteration, it means repetition. Constructs, in the sense, the things that will help us for iteration. So there are many actually. So in the iterative constructs, we have some instructions which are repeated in a loop, and we do it in a very specific way. Loop in the sense, the one which is going round and round all the times.
Yeah.
Okay.
Keep
And
up. Yeah.
yeah, exactly. And the loop is initialized also stating when the loop will be terminated. So we will initialize the loop, in the sense we will say when the loop is actually going to start and when the loop is going to stop. We will tell it. All the things will be already specified. Uh, in any program, we will specify when the loop has to start and when the loop has to end.
Mhm.
Then there will be also some testing loops. What do we mean here? Testing loop, it means the loops which are based on some condition. Like we have some conditions for the loop, and if that condition meets, then the loop will run. If not, the loop will stop. Okay.
Yeah.
And terminate the loop when the result satisfies the condition. For example, I'm giving you an example. I have a loop called for, and I say for has to start. Just a moment. Okay. I don't know how to stop it. Okay. Yeah. So I have a loop called for, and I say I is greater than 1. So I say for is a loop this for is the name of the loop which is starting at the condition where I is a variable which can be any number. If this number I is greater than 1, then
Mhm.
the loop has to start. Then at the end, I say I is less than 10. This is just for your understanding.
Yeah.
It's not exactly the syntax that we use for programming, but just for your understanding. So at the end of the loop, what I'm saying, this variable I, which stores some values, has to be less than 10.
Yeah.
So we are starting the loop at any value which is greater than 1 and ending the loop at any value which is less than 10. So the loop will run from 2 to 9. The loop will run from 2 to 9.
Okay.
Clear?
Okay. Yeah.
Yeah. Then there are two types we will see, while and until. I will not explain about it now, but only very brief, I will tell you what is meant by the while loop and the
Like also math,
until loop.
numbers?
Yeah, sorry.
Is it also numbers?
Yeah, it will also take numbers. It will also take numbers, and sometimes it will also take strings. Strings means characters. The alphabet that we use in typing, that can also be used. So this is actually called a while loop. And in the while loop, the condition is in the brackets here. And whatever we want to write, the body is here. The instructions will be written here. So this is the while loop. And
Can I say something?
yeah,
I will
please.
never understand any numbers, any things that between each other, between things, without writing down and having like examples and many things. So keep this on a side. We will do it again.
Okay.
It's hard for
All
me.
right.
I'm really not
All
good in
right.
math.
All right. For sure. So now we are doing this while loop, which is called as a pre-test loop. We tell it pre-test. Why do we say it pre-test? Because
Before.
before actually something enters, we are testing it here itself. Along with this while, we are testing the condition here, and if condition meets, it goes inside, or else no. Okay? So there is another loop which we call it as post-test loop. The test is done after execution. So what is this loop starting? It's starting at repeat, and it executes something until the condition is checked at the end. The condition is being checked at the end. So we call it as post-test loop. The test is done at the end. So these are two different types of loops that we just explained. And in the while, there is repeated execution, and that's why it's called as iterative loop, repetitive loop. Example, when books remains to be finished, keep on reading. This is one of the example of while loop, where we can ask a computer to read a full file or to read a full book until the book is reached at the last page. Clear? So this is condition, and this is running. It will read page 1, page 2, page 3 until page 100 or the end page of that particular book. There is also a loop called for loop, which is little different from the pre-test and post-test loop, but it has more, we could say it has more features. Like it will help us to increment one by one. It will help us to increment one step by one step from one number to other number. And the syntax I have already shown you in the last slide, right? Yeah. So if you want to see it here, also we can see it.
Okay.
We are starting with a variable called sum, which is at 0. And for all the elements in the list, we say sum has to increase by the 0 and that element. So each time we are incrementing by 1. So this is syntax of the for loop. We have seen for, we have seen while, and we have seen repeat and until, right?
Okay, I have a question. We do
Yeah.
loop in syntax
Yeah.
in programming, so like the orders that we put or the the syntax we put
Yeah.
that can be
Yes,
repeated.
yes.
Okay,
Yes, yes.
so
It
repeat by what?
syntax has,
Like a specific program
yeah,
or just in any program?
yeah. The syntax is same for any program. It doesn't change.
Mm-hmm.
There are some ways of syntax. If we used this for syntax, there are 2 to 3 ways of writing for loop. And in every program, you can use only those 2 to 3 ways, no more than that. So syntax of the loops, functions, and some of them are defined. They don't change at all in any program. We just have to know how to use it in any program that we want.
Okay, good.
So once we understood programming, it's the most easiest thing. Since the syntax doesn't change, and lot of definitions and the way we have to write, it doesn't change at all, right? Okay. Now we will also know another topic called function. Like I told you yesterday, function, it means just something which will do some task and give it to us. For example, a receptionist, what is her function or what is her work? Her work is to check who's coming in her organization, note it down, or whatever they need, she has to guide them there. This is her function. This is her task. Likewise, we can define different functions in a program, which will do work part by part. We can say it as employees in an organization. Like there are employees in an organization for different kind of work, there are functions in a program for different kinds of work. Right? Clear? And how can we define the function? We say def. What is this def? It means definition. We are trying to define the function, and after that we should give name. Like we have, every employee is given an ID, and also along with their ID, they have a role. So as per that, we give them email ID and an employee ID and all of these stuffs. Likewise, here we are trying to define the function name as per its function, like whatever it does, we will give the name like that.
Yeah.
If we want to calculate bonus of any employee in our company, I want to make a program. I will say, for making this program, I'll use the function calculate bonus. Why I'm doing this? Because I know I want to calculate bonus. So I am naming this function calculate bonus. And this function will help me define the whole task of calculating bonus. What we will write here, we will not see it now because it will be a bit confusing for us at this stage. So we'll skip it and we'll just try to understand the overview of all of these things, inshallah. Okay. Next, how to call a function. Now we have defined it. It means we wrote it, what to do. Now it's the time to take action from a function. How can we take a function? How can we call a function? That using a function, we call it as calling a function. Let's take the example of receptionist again. We have hired a new receptionist. We give her ID, we give her emails, and we give her all the stuff that are required in our organization. Now, let's suppose you are the manager. You have the extension of the new receptionist. You'll just pick your phone and call by the extension of the receptionist, and then khalas. You will tell her whatever work she has to do, right? Likewise, when we want to call a function, we have to use the proper name of the function. This proper name. The name is calculate bonus. We have to use it as it is.
Mhm.
So wherever we want to call, we will not use definition because it's already defined. We just take the name and call it.
Yeah.
Now, why do I keep if here? I'm saying if there is some condition, like if I need a coffee, I will call the receptionist. Else, I don't need or pay commission, something like that.
What
Here,
is
yeah, pay commission is another function which is trying to pay commission, which will calculate the commission and will pay. So we'll not discuss about it now. Let's go slow by slow, one by one. If you need a coffee, you will call the receptionist. Else, don't call the receptionist. We'll just say print, don't call the receptionist. We'll not use this pay commission now. Okay. I hope you understood how to define a function and how to call a function. There are
Okay.
two different terms that we use in programming. One is defining a function and one is calling a function. And these two terms are really very important and you should know it. Like if anybody say, how can you call a function? You can say that we use its name wherever we want with these braces.
Yeah.
This curved braces, we use it. Now, let's see here. There is a very good example of a function which is doing search task, which is trying to search something in a list from beginning to ending. What we are doing, we are saying define a function called search, and it's taking list as the input, list of names or list of values. It could be a full file which has all list of values, and will also give the final value. The final value, it could be 100, for example. Now, once the definition of the function, the first line is done, the cursor or the computer goes to the second line, and at the second line, we have to check if the list is empty. Why we are trying to check if the list is empty? If it's really empty, we will declare nothing to search. Same way, I'll give you example of receptionist again. We are trying to define a function called receptionist. If reception is absent, no need to call her, right? If receptionist is absent, no need to call or no need to tell her any word because she is not there. Likewise, if the list is empty, we should declare that nothing has to be searched. Else, if the list is not empty, we have to go to the first entry, the first item in the list, and we have to use a loop which will run from the first value until all the values.
Okay.
Until the full values, and each time it has to move to the next value.
Okay.
What is our target value which we want to search? And what is this test entry? The one which is captured here, like it can be the first item or second item or third item, that is test entry. If we found that equal, it means we have found what we are searching for. Else, declare value not found. Okay? So whatever is it in blue color is actually syntax. It's actually the keywords that are used in writing a program. So now you are familiar with these things. You are familiar why we use def, D-E-F, for defining a function, why we use if for checking some condition, and why do we use else for taking alternate of that condition. Why we use why to run a loop for any number of times from starting value to ending value.
Okay.
And if again a condition to check something, if that condition doesn't mean else.
Okay.
So these are like a way the flow of how a program runs, and this is how we define a function, and we are doing it iteratively in a while, and we are also checking the conditions using if. I hope you understood this, right? Yeah. Actually, this is not the full program. We are writing in human words, right? Declare value not found. We are saying declare value not found here. We are saying move to the next entry in the list as temp, right? So this is human understandable for our understanding. And you understood it. Though you are not from computer programming background, you understood it. And this is how a pseudocode is written. This is what is the example of pseudocode that we see already yesterday. So now we've written our pseudocode. We have to see how efficient and how much time, how scalable, and how much space does our program will occupy in a computer. So let's go back a little and we'll see our pseudocode. Where is our pseudocode? Here. So here we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So let's consider there are 11 lines that have to be executed by the processor. Who's the one who's executing all of these things? The processor of any computer. So let's consider the processor will take 1 minute to execute one line. And it will take 1 KB memory for each line to execute. So can you tell me how many minutes it will take to execute these 11 lines? We told one line will take 1 minute. So how many minutes will these 11 lines will take to execute fully?
Again, for the first, how many minutes for
First line, it will take 1 minute, and we have 11 lines. How much time does our full function execution will take?
11 minutes.
Very good. This is for simplicity for your understanding. Likewise, if I say each line, it will take 1 KB of memory for execution. So how much memory does the full execution of this function will take? 1 KB. KB means kilobytes. Kilobytes, okay? So how much all of this will take?
How many minutes?
How many kilobytes? Memory. I'm asking about memory. If one line takes 1 KB, 11 lines will take 11 KB. Yeah, exactly. 11 kilobytes per. So from this, what we are trying to understand is when we write any program, any pseudocode, we should identify how complex it is. How much time does it take? And how much space, memory does it take? And how efficient it is? Is it running correctly or no? So all of these things we have to check as a programmer. And all of these things are called as algorithm complexity.
Yeah.
So what is algorithm complexity? Algorithm complexity is a kind of function, or it's something which will measure efficiency of a program. How efficient is the program based on some metrics. What are the metrics? How fast is that program or how slow is that program? The first metric is time. The second metric is how much resources like space, the memory it takes, and the computations it has to do on our computer. We will measure that. Based on these two metrics, the complexity of any algorithm is identified. Right? Clear? Now, let's move a little forward. There are like some of the measurements that we can do for identifying the complexity of a function. The first is we say as space complexity. Space, as the name suggests, space, it in the sense the memory space that algorithm takes in the computer memory. Okay. So when we say algorithm complexity, there could be some more things inside it. One is the space complexity. Second is the time complexity function. So as I told you, how much time does it take to execute fully? Right?
Mhm.
So yeah, next. How can we analyze the complexity of any algorithm? We took two, space and time, right? Space and time. So in that, best case analysis. The first is best case analysis. Second is average case analysis. Third is worst case analysis. So these are three kinds where we need to identify best case, average case, and worst case. I'll tell you with an example, okay? I have given you 100 numbers, okay? And the 100 numbers, I told you they are unsorted, they are random. And I give you it in a file. I asked you to find some number 33. Since it's unsorted, you cannot quickly find it, right? You have to start from the first number, which is at the first row, and come down until the last row, which is the 100th row. Are you understanding? Yeah, we have numbers. We have number that are written in 100 rows. Okay, I have a file like an Excel. Okay, like an Excel file. And I am saying that we are writing we have written all the numbers on this Excel, but they are unsorted. Let's consider the first number is 2, the second number is 24, and third number is 33, so on. And likewise, there are 100 numbers. And all of these numbers are from 1 to 100 only, but they are unsorted. They are random. Now, when I tell you, find the number 33, and let's consider that 33 is in the third place, third place, like this example. And you are searching it. You are lucky in this case because it's just at the third position. Okay. Next, consider in the other scenario, this 33 is at the first place. The first place, it means the first row here at the place of 2. So if it's here, you'll find it just in less than a second, right? So this case is called best case analysis, where you were able to execute, you were able to see it in the first case. Yeah. This is the best case. So it doesn't take very much time and it doesn't take your energy. Likewise, if we give this list, this file to computer and to search the number 33, which is at the first row now, the computer will take the list and the computer will begin it too. And at the beginning itself, it will find the number 33. So in this finding, the computer hasn't used much of its resources, no space and no time. And so it's called as best case. So the best case, it means the very best, where the computer can perform. It also depends on conditions like where is the place of 33, likewise. Average case. The average case is the place where the number 33 is at the 50th position. 50th position, exactly the middle of that Excel sheet. So when you are finding, let's consider you are taking 1 second to check each row. Then you will find 33, which is there at the 50th position. At which second? You will find it at 50th second, right? Shall I come again? Yeah. So number 33 now is at 50th position. It's there at 50th row. The number 33 is there. Okay? So If you are taking 1 second for screening one row, then how many seconds will you take to find this 33?
33 seconds.
No, 33 is there at the 50th position, the 50th row. Then one row is taking 1 second. Then 50th row screening will take 50 seconds, right?
Yeah.
Okay, shall I tell you with an example of row?
No,
I mean, you got it, right? Fine. Likewise, let's take the example of computer now. Let's consider our computer is taking 1 second also to find one row. Then it will take 50 seconds to find the 50th row and to find the number 33. So this is the average case analysis where the computer will take half of its time. The program will take half of its time. Now, what could be the worst case? Can you give me an example? What could be the worst case and our number 33, where it can be or where it has to be to take worst time, to take the maximum amount of time for searching?
I don't know.
Okay. We said the best case was, okay, all right. So we said the best case was that we found the number 33 at the first row, right here.
Yeah.
And we said the average case was to find the number 33 at the 50th row, the row which is 50. Yeah. And we said that we have all 100 numbers. So the worst case would be to find our number 33 at the 100th place, which is the last of our list, right?
Oh.
Do you get it now?
Yeah.
Okay. So it means the worst case would be the place where our number is at the last of the list. So this is how we analyze the algorithm. When we have written one algorithm, we will try to test it in every way. Your algorithm is trying to search row by row, right? Row by row, like each row it's trying to search. So if the number is at the first place, it will find very quickly. If the number is at the middle, then it will take half, like 50% more time. If the number is at the last, it will take too much time. Oh, yeah. So when we found the 3 cases analysis, what can we do? How can we improve our algorithm? I will give you one hint. In the beginning, I told that these numbers are not sorted. But how it will be if we sort these numbers? Yeah. If we just run a sort on this Excel, we have functions here where we can keep increasing and decreasing. We can filter the numbers, right? We will filter the numbers and then we will sort it from top to bottom. Once we have sorted, we know where 33 will lie, right? 33 will lie like at what place we know. We'll just directly go to the 33 number and see it. Clear? So this is how we can improve our algorithm, by improving the techniques, like improving some changes.
Yeah.
Now, how we can apply the algorithms, how we can implement or code the algorithm is by programming language. And programming language have different data types and data structure. What do we mean by data type? Is the type of data that we can store for any program, and in what structure, in what method can we store that data. We have that. And we have control constructs which I told you, for loop, if loop, these things. And
Mhm.
all of these things can be used to apply algorithm and to implement it and make it runnable or code in the code. Now let's check what we have learned from the above. Okay. Now match the word in its correct definition. Match the word in its correct definition.
Okay, defines a problem and shows. Uh, program
Yeah.
is a step approaching, right?
Do you remember program is interchangeably used with algorithm? So
Yeah.
the meaning of program is similar to algorithm, but here there is something explaining about algorithm, step-by-step approach of executing an algorithm. It means step-by-step approach of executing a program.
Mhm. Oh, okay, okay.
Yeah, it has to be this one. A program is, it means it defines a problem and shows how it can be solved by
Mhm.
an algorithm. Okay. Okay, this is way to match. Okay. Yeah. Now let's try the other one. What measurements can be used to determine algorithms complexity? What measurements, what things we need to measure to determine that an algorithm is complex or not complex?
Space
Space and
and
what
length.
is the next? Length?
No, no, no,
No,
no,
we
no.
have not checked length.
Space and detailed function.
No.
Time.
Yeah. Do you remember every time when we are discussing about any algorithm, we are always discussing about time, like how many seconds and how much memory, right? So these two things are important in algorithm complexity. Next, which loop in this image is represented? This is repeat, body, until, and here is the condition. Is it the pre-test loop or post-test loop?
Post.
Pre-test? Yeah. Pre-test is the one which is tested before it's actually entering the body. Post-test is the one which has already entered the body and the test is after execution. So it was very good that you understood the mashallah very nicely today. And now we will talk about the high level programming language. Okay, this is not too much, so I want to continue here and we will finish it up today. Okay, as I told you yesterday that high level programming language, like the languages of ours, and high level languages that we use are natural languages. They are similar to pseudocode and they are not machine understandable. They are not machine dependent. And we cannot feed the machine the same language that we understand. We cannot feed high level language to the machine. We cannot feed the pseudocode to the machine, but we need some some code that is understandable to the machine, and we could call them machine language, machine instructions, or low level language. We can call them like that. And all of these machine language are compiled, are run by a compiler. That is one of the most important component in a computer, which will compile our language to the low level language so that the computer can understand. And there is translation process where one, this is very good here for us to understand. So here is the source code. What do we mean by source code? The high level programming language which we will write, like C, C++, and so on. All of these languages we can understand. We
Yeah.
have learned it, then we can understand. So that thing we call it as source code. So remember this particular thing, source code. And this source code is fast to computer.
Source code is we put like the language that high and the high level language that we choose, like C, C, C plus C, or Java.
Exactly. You're right. Absolutely right.
Where should we write like what we are doing?
We have to write it in any tool which can compile these languages. If we are using Java, we have to use Java compiler. If we are writing C or C++, we have to use that compiler.
So
Okay?
before we have to write what we will do.
Yeah. Now a quick question for you. This is the source code, which is programming. The pseudocode will be before this or after this.
The what?
The source code is here.
Yeah,
Pseudocode. I'm asking about pseudocode. Pseudocode is the step before this actually. Pseudocode is not C language code. It's just written English sentences, right? Written code. So pseudocode will be before source code. Before actually writing the high level programming language, we write a pseudocode, we write a flowchart, or we write an algorithm. Then we write a program which consists of pseudocode, which consists of high level programming language, where we'll have all steps of the program. We write it on any interface or the compiler, whatever we are choosing. After we compile, there is something which will analyze the code, and that thing is called lexical analyzer. As the name suggests, it is lexical analyzer. So whatever is written in the input, it will take it as token. It will take it part by part and give some meaning. It will try to understand what the tokens are. Token, it means it's just a part of a program, and then it will try to understand, analyze what is this part, and will try to parse in the sense analyze again. After doing this, all the tokens will be sent to a parser. Parser, it means it's a kind of understanding thing, or it's a kind of tree which will categorize things, and it will add grammar to the language. Yeah, this is a very good explanation. Like once the tokens are categorized, once they are a bit like only basic definitions are added here, and here the grammar is added to the language. The grammar is not our grammar, it's the grammar of machine language. Then the code generator. The code generator, it means it will construct all the language instructions for the machine. This was our instruction. This is the machine instruction. It will generate, and then it will compile. Here we could say it is compiled and the program is run, and here is the output of the program. And whatever is the output, we will see it on the screen. This is the whole process of executing from high level programming language to the low level machine language. Okay. And let's see what will be there in high level language. The high level language will have constants. Constant, it means any number, like 1, 2. 1 is a number. When I keep a 1, it means it will be 1 always. The 1 is not changed until I remove that 1 and keep something else, right? If I keep A equals 1. So that value of A will be 1 always until I remove or erase A equals 1 and keep A equals 2. When there is a number, it means it's a constant. Okay? Any number is constant. Next, data type. What type of data that we are using? In programming, we need to use integers, we need to use decimal values, fraction values. Sometimes we need to use alphabet, sometimes we need to use just characters like A, B, C, only letters. All of these things. And high level programming language, it also consists of functions. We know what is a function. Control structures like loops, we know what is that. And all of these things, packages, procedures, modules, and libraries. Each of these things I'll not explain you now, since it's even if you understand it now, you will forget it later. So rather than understanding it at this point of time, we'll discuss it later in the upcoming modules, inshallah. So in this module, they will give you a very basic programming language, Python, which is very easy to program, and even I could say it's more easier than the first programming language like C or C++. So we will do some exercises with the Python programming language, like how we can initiate two numbers, how we can store the numbers, how we can define a function, how we can create some conditions, and how we can use plus, minus, and how can we see the output. All of these things we will learn in Python now. So we are entering into Python programming language. The first thing we need to know is data types. What is the type of data that we want to use in our program? We should know about it. Data type, it means what is the type of data. When we say integer, it means whole numbers, all the numbers from 0 to 1. Even minus numbers also, like negatives. Integers, you know the scale, like scale of numbers. I think you know it. From minus infinite to plus infinite, the integers will take.
Yeah.
Okay. Yeah. Like if we see the number line, 0, 1, 2, so on until infinite. And likewise, -1, -2, so on, minus infinite. So all of these numbers could be categorized into integers. Likewise, float values. Float, it means all the real numbers, all the numbers with fractions, like 0. If we say 0.2, 0.8, or 4.9, something, okay? All of the numbers which consists of decimals, that will be categorized as float. And next is a character. Character, it means any symbol or any letter, like A, like B, okay? Any symbol, or ampersand. This is a symbol, right? So all of these things will be considered as character in programming language. Next is a Boolean. Boolean, it means true or false, two values, true or false, 0 or 1. The true is considered as 1 and false is considered as 0. Or we can use it either way around, it's up to us. But in most of the cases, true is used as 1 and false is used as 0, okay? So there are 4 types of data types that we'll be understanding in this lecture. First is integer, which is whole numbers, and float is the real values, and character are the symbols, Boolean are true or false.
Okay.
So let's try to define it a bit. Define it. Float could be some number which can be decimal, which can be fraction. So area can be decimal, right? Any area, for example, let's take area of a flat could be area of a flat. We don't know how much it will be, but for our understanding, 22.6 square yards. Can it be there? Yes, it can be there. Whereas can the
Hello.
yes, can you hear me?
Yeah.
Yeah. Whereas the salary, it can't be decimal. It has to be an integer. It has to be a number. Likewise, the character has to be some address. Character in the sense like my flat, if I say it's some number, at the end we have B. If we say like sometimes they have characters, some numbers, not the numbers. Just a moment. Okay. Yeah. So characters, as I told you, any alphabet, any letter that we can use for the character. Here, now we are saying that salary is an integer since it cannot be a decimal. And we are keeping the salary as 10,000. Are you with me, Fatma?
Yeah.
Yeah. And how we define this variable? Salary equals 10,000, and this is of integer type. This is how we define any data type in Python programming language. And this syntax is same in C and C++ too.
Mm-hmm.
So if you know this line, it means you have defined a variable called salary, which is storing 10,000 in that. Okay?
Mm-hmm. Okay.
Now, control statements. How we control programming in Python. We have dealt it already. The if statement, which will take some condition, and based upon that condition, this statement is executed. The statement after this column. If in Python need to have these blue colored things for sure. If some condition, it could be I equals 0, then some statement. If this statement is not satisfied, then the else statement and statement 2. Okay?
I think this material we have to study it face to face because I can't get math online.
Okay. All
I
right.
don't
All right.
actually.
Yeah. Okay, sure. So this is the last of today's lecture actually. There is nothing much in this. Here, I can show you with the Python program in the next class.
Mm-hmm.
Yeah, in the next class, I'll show you a Python program and that will really help you to understand more, inshallah. I think my voice is echoing. All right. And while in Python is same as we explained you before, while condition and whatever the body that is needed here. So output, now we will come to the output. Whenever we write any program, the output of the program should be understandable, should be as we wanted. It has to be accurate, and it has to be timely, and it has to be action oriented. What all of these means? I asked you to give me a program which will make addition of two numbers and give us the output. And you are writing. When you are writing the program, I give you two numbers, 2 and 5. And your program says the addition is 15. I give numbers 2 and 7. It has to be 9, but your program gave me 15. So is that accurate? No, it's not accurate and it's not meaningful. Likewise, if your program is actually giving right output, but it's taking 1 hour to execute, it's of no use. It's not timely and we cannot depend on it. And we don't need that kind of result from any program. So we need to have a good program which is meaningful, action-oriented, timely, and accurate. For that reason, we need to test every program for its correctness, and for validity. So for correction, for testing it, we have to check each and every line of the program or each and every function of a program. So there are different types of testing like unit testing, integration testing, and quality testing of the program. So these tests are not very much important for you, so we will skip that part. But there is one quiz question for you to understand. So we need to match the data types with the correct description. Let's start with the very simple thing, integer. Okay, do you remember integer? Is it whole numbers or is it a number with fractions?
A whole number.
Very good. And now the real or float is the one which is the remaining. It's not the whole numbers, but it's the
Numbers of fraction.
very good. This is numbers with fraction. Now the character, it means as we told you the example of address, symbols. Very good. Next, Boolean is
Yes
either
or no?
1 or 0, true or false. Very good. So this was your lecture for algorithms and programming. So we are done with the unit 4 too. And inshallah, we'll continue in our next class. And do you have any questions?
No, just send it to me, the record, so I can
Okay, sure.
read
Okay, sure.
it and understand again.
Yeah, sure. Thank you very much. All
Thank
right,
you.
Fatima. Thanks for your time. See you again, inshallah. Okay. Assalamu alaikum wa rahmatullahi wa barakatuh.